Today we are going to look into inequalities. And we can have inequalities in one variable or in two variables. We have been studied by now equations. Equations, if you want, are also equalities. So we studied equations like, for example, how to solve 2x plus 1 equals 5, find x, yeah? Or systems of equation. For example, 2x plus y equals 5, x minus y equals 3. Simultaneous equations. Equations contain an equal sign. Inequations contain less or bigger. So we'll have inequalities in one variable, for example, 2x plus 1 smaller than 5. X minus 3 bigger or equal than 4. 2 plus x bigger than 3x. So we need to find what x verifies each of these. Or you can sometimes have double inequalities in one variable, like 3 smaller equal x plus 4 smaller 7. That's how we read them. Or negative 2 smaller than 2x plus 1 smaller or equal than 3. Later on, we'll study inequalities in two variables. For example, 2x plus y smaller than or equal to 4. X plus 3 bigger than or equal to 3. These have two variables, x and y. Let's get first familiar with the notation. This sign means bigger than. So I can write x bigger than 4. I remember it because the mouth of the sign opens toward the biggest number. So x is big, see we have a big space here, and 4 is small because it's like the angle closest towards 4. So x is bigger than 4. Then we'll have this sign, means bigger than or equal to. Bigger than or equal to. So if I write x bigger than or equal to 4, in the first case, 4 will not be part of the solution. So we start immediately after 4, whereas here 4 is included in the solution. If I want to represent this on the number line, where are the numbers that are bigger than 4? See how 4 is here on the number line. So the way I represent all the numbers starting from here to the right are solution. 5 is bigger than 4, 4.5 here is bigger than 4, 5.56 and so on. All numbers here are bigger than 4. So the way I represent my solution is on the top of number 4, I'll put a circle to show that 4 is not included in the solution. Yeah? And here is x bigger than 4. So this line that I'm drawing comes together with the number line. And see, it starts from 4, yeah? And 4 is not included, meaning that this circle is empty. If I want to represent x bigger or equal than 4, this is how I represent it. X bigger than or equal to 4. I can have less. So less than. For example, x less than or smaller than, let's say 2. Less than or equal to. X less than or equal to 2. The way I represent them, yeah, if I have a number line, 0, 1, 2, and so on, x smaller than 2, it's here. All these numbers, see, minus 1, minus 2, all those numbers here are less than 2. So this is x smaller than 2. And x smaller or equal to 2 will be represented like this, meaning that 2 is included. Yeah? Any number here is part of the solution x less than or equal to 2. Sometimes I can have double inequalities, like for example, -2 less than or equal to x less than 4. So if I want to represent this, see a -2 is involved, -1, 0, 1, 2, 3, 4, 5, and so on. Let's put a -3 here, yeah? And this tells me that, see, I can split this into 2. This is the same as -2 smaller equal than x, and in the same time, x smaller than 4. If you read this one from the other side, you see x is bigger because this sign is open towards x, so x is bigger than or equal to -2. Sometimes it's easier to look at this in this way, x bigger than or equal to -2. And in the same time, x smaller than 4. This means that x is bigger or equal to -2, but in the same time is less than 4, so I need to stop here. So this is my solution for this one. This is how I represent it on a number line. See, I don't really go and represent exactly, I draw this on the top of the number line because then I will not see it, so I draw it just on the top. I don't draw it on the number line, I just draw it on the top. On this page, you are given 3 representations of the inequality. 1, 2, 3. Can you please pause the movie and just write what each of them represent? What x is here, what x's are here, and what x's are here. Just write on the top of each. So the solution should be here, x bigger than or equal to 1. All x's that are highlighted are on the right of 1. Here will be x smaller than or equal to -2. No, it's not equal, it's just smaller than, because the circle is open. And here I will have -1 smaller than x smaller than or equal to 2. So these are the 3 inequalities represented here. What happens if I am asked to represent an inequality that looks like this? 2x plus 1 bigger than 5. I need to get something like x bigger than something or x smaller than something so that we can represent them. So I need to leave x on the left hand side. It is exactly like solving linear equations, with just one single exception, which I'm going to show you later. So if I'm looking at both sides, it's like you have a balance, but you know that this side is heavier than the other side. Because you know that (2x plus 1) it's heavier than +5. It's bigger than +5. You solve it same as you solve linear equations. So if you subtract 1 from both sides, the balance will still be inclined towards the left. So you'll be left with 2x bigger than 4. If you divide both sides by 2, you get x bigger than 2. So your solutions are all numbers that are bigger than 2. And this one is the same as 2x plus 1 bigger than 5. And that's your solution. How about an equation like that? First, we might do -7 on both sides. So get 5x less than or equal to 3x. Oh, sorry, to 3x minus 9. Yeah. Take away 3x from both sides. So you have 2x less than or equal to -9. Divide by 2. And we get x less equal than -4.5. So on our number line, if here is 0, -3, -4, -5, and so on, then -4.5 is somewhere here. We include -4.5, and this is your solution. Yeah, so all the x's that will verify this inequality will be here. Let us solve this equation. The way we will solve it will lead us to something interesting. Maybe your first thought would be minus 5 on both sides. So we'll have 3x smaller than 4x minus 4. Then we want x is all on one side, so we have minus 4x on both sides. To get rid of 4x from the right hand side, 3x take away 4x will give me minus x smaller than minus 4. Now to get x, I'll need to multiply everything by minus 1. Same as we've done with the systems of equations. Minus x times minus 1 will give me x, minus 4 times minus 1 will give me 4. The difference is from equations that when you multiply by a negative, this smaller than will change into bigger than. If it was bigger than, it will change into smaller than. It's easier to look at x bigger than 4. 1, 2, 3, 4, 5, 6, and so on. Negative 1, negative 2, negative 3. So here is my number line. If your x is bigger than 4, it means that x is everywhere here. So every of those points can be your x, like 5, 6, or 4.5, or 5.5. Any x here is bigger than 4. Now imagine what's going to be with minus x. If you change the sign, 4 changes into minus 4. Yeah, so this 4, if x is 4, minus x is minus 4, it's come here. If x is 5, minus x is minus 5, will come here. If x is 6, minus x is minus 6, so minus x's will come here. So see how x bigger than 4 is the same as minus x is smaller than minus 4, because it's just a reflection. Oh, I forgot x equals 0. If it's a reflection on 0. In order to remember, in order to solve inequations, we do the same things as solving equations. The only difference is that when we multiply by a negative number, we need to change the sense from smaller to bigger, or from bigger to smaller. Now you can try these questions by yourself by pausing this video.